Hello everyone. Uh, Welcome to the tutorial session of the network analysis. This is the eighth tutorial session of the network analysis, whose instructor Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur, and I am Satyakant Pratap Singh, a PMRF research scholar at Department of Energy Science and Engineering, IIT Bombay. So, in the last classes, we have discussed about this some of the questions related to network analysis and some of the methodology how to find out the cut set, tie set, and other kind of matrices, suppose incidence matrix as well. And also we have seen if there is a dependent sources are there, so how to calculate the values of this Thevenin voltages and Thevenin impedances. Okay. So in this tutorial session, we will see few of the theories related to network analysis, and we will solve the few of the problems related, some of the objective problems and some of the kind of numerical problem. And after that, we will see that how to find out the matrices of the different kind of networks, and we will go through the question wise as well. Okay. So, starting the theory session related to this graph theory. So, graph theory is basically a network analysis which refers to the study of the graphs, which can be a mathematical structures like in the matrix form. Okay, it is used to represent the networks of the interconnected nodes and also known as vertices and the edges. Okay, suppose you can see in the figure as well. So, this is a one network theory network which is given, and this skeleton you are seeing in the opposite side, this is actually the graph of that network. Okay, so if you have seen that there is a voltage sources which are being sorted, and the resistance is also being represented with this branches. Okay, so this A, B, C, that is the nodes. Okay, they are similar as which is being seen in the network as well. Okay, so this is the A, B, C, D. These are the nodes basically. They are the interconnecting points, and the branches which are connecting in between the B and C and the two nodes. They are called as the edges. Okay, so these are the edges. Remember that what is the node and what is the edges. Okay, if you see here the graph theory, it is consists of basically the two things. That is the node, which I have given that this is the nodes. These are the nodes. And these are the, if you can see, these are the branches. These are the vertices, edges, or the links. Okay. So this 1, 2, 3, 4, this 1, 2, 3, 4, they are actually the nodes. Nodes of this graph, and A, B, C, D, E, F. They are actually the edges or links. Okay. So if you see by the definition as well, the nodes and the vertices, the individual entities in the network, such as the junction in the electrical circuit individually, means which can be seen in the social networks or in the computers in the communication systems as well. Okay. And if you see the edges, the definition, the connections or relations between the nodes. That is, if you see the in between the 2 and 3 node, this is the interconnecting point, interconnecting means edge that is called as D. Okay. So in the communication network, this might represent the transmission links, or in the social area, they are the edges which represent the friendship or the interaction between the two nodes. Okay. Suppose one current is flowing between the 2 and 3. So this is the current based interaction between the two nodes. Okay. And the graph definition is that it is basically the skeleton representation of the circuit of the network. Okay. But the very element, it's very important to know that this where every element is suppressed by its nature and represented as a simple line segment. Okay, they are the nature. Suppose they say resistor, they are the inherent property of resistance that so to make a power loss. Okay, and also capacitance to store charge, inductance to store flux. So they are the inherent properties of this element, but which can be represented with these edges only. Okay. So there are different definitions inside of this graphs, that terminologies like nodes, ages, degrees, paths, or cycles. Okay. So nodes basically, so which we have represented. Suppose this is a one graph which I am making. Suppose this is a graph, and these are the nodes one, two, three, four. Okay. And these are the branches A, B, C, D, E, F. So these are the actually nodes. Nodes are one, 2, 3, 4. They are the fundamental units in the graph representing an entity in the network. Okay, so these are the nodes, and edges are these are the connection points between the two nodes. They are called as edges. So these are the nodes, and A, B, C, D, E, F, they are actually the edges or links basically. Okay, and there is a third definition which is called as the degree of a node. Degree of node means, suppose this is the number of edges which is connected to the node. Suppose in this graph, suppose I am considering the node 1, okay, and I am interested in finding out the what is the actually the degree of this node 1. So for finding the degree of this, so there are three connection points here. So if you see that there are three edges which are connecting to this node, so its degree is usually considered as a 3. What about 3? Node 3, here also the three connecting branches are there. Okay, so they have also have the degree 3. Okay, so these are the means node definition, edge definition, and the degree of the node. What about the path? Path is the sequence of edges that connects a sequence of vertices in the network. Suppose I'm saying ki, you I wanted to go from a node 1 to node 3, so there are two paths. One, I can go through the branches B and D, and one I can directly go from 1 to 3 with the branch of A. Okay, so the path means the connection points between the 1 and 3 is a path. Basically, it can be A as well. It can also be a B and then reaching to the 2 and then going to the D, going through D. Okay. So this is a one path. This is the sequence of the vertices in a graph. Okay. What about the cycle? Cycle is usually a closed path. Suppose I have taken this only the same example here. This is the node 1 and node 2, node 3. Okay. Suppose I have started from the node 1 and went to the node 3 and then came back to the node 2 and then came again to the node 1. So this is a kind of a circular path. Okay. So this is known as a cycle. Okay. So the path which starts and end at the same node, they are form a loop which is called as a cycle. Okay. So these definitions you have to keep in mind, that what is the definition of node, definition of edges, definition of degree, definition of path, and definition of the cycle. Okay, and there are different terminology also, that there is a sub part also of a graph. Suppose this is the graph which I have taken the example. So this was the graph. So suppose I have taken the one part of it. Suppose I am taking this part. Okay, so this is cycle and also a sub part of this graph. Okay, so this is called as a subgraph, means a part of the graph. Okay, so there the definition, if you can see, the a basic structure of node and edges which can be directed or undirected. Undirected or directed means, it means that ki current direction when it is given, suppose this is given like this, so these are the at each edges, each direction, each means branches, so they are called as the directed graph. Okay, if this arrows or the direction is not given, so this is called as the non-directed or oriented non-directed graph. Okay, or you can say the undirected graph. Okay, so this is the basic definition or difference between the directed and undirected. What about the subgraph? It is a subset of a graph containing some of the nodes and some of the edges, where if you can see here also some of the nodes, some of the nodes, and some of the edges basically. Connected graph means a graph which is there is a path between the every pair of the nodes. Okay. Suppose I am taking this graph. Okay, like this. Okay. So this graph basically, if you can see the node, suppose this is 1, 2, 3, 4. So 2 and 4 don't have any connecting point. So they are not connected basically. So this is not a connected graph. If there is a path between the each node, connecting node, suppose 3 and 4 is also being connected. So this is called as basically a connected graph, where the each node is being connected to another node. Okay, through one or more than one path. Okay. Directed graph or oriented graph, which I have already explained that it must be given that the direction of the current basically. So from which node to which node the current how it is flowing. Suppose from the A to B or B to A basically. Okay. So these are the what we have learned. So we have learned the graph. What is the graph theory? Second, we have learned the what is the node, what is the edges. Third, we have seen the node, edges, degree, path, and cycle. Then we have seen the definition of the graph, subgraph, connected graph, and directed graph. Okay. Now the one most important part is the tree. Okay. So listen carefully. What is the definition of the tree? Tree is basically a connected graph with no cycles. Okay. No cycles mean there will be no any path which is starting from the same node and ending also at the same node. Okay. So most important part is there is no cycles in a tree. And in the network analysis, tree is important for analyzing the network structure because they ensure that there is a single path between the any two nodes. Okay, which is necessary for routing and minimizing redundancy. Okay, this is the most important part is that there is a no cycles. Okay, but second point also, all nodes will be part of tree. Getting my point? So there will be no cyclic formation, but the each node will be the part of the tree. Okay, whatever in the graph. Suppose I'm taking this example. Okay, 1, 2, 3, 4, and this is the A, B, C, D, E, F. So these are undirected graph because I have not given the direction of the current or orientation of the current inside of the branches. Okay. So now if you see, if I make that, I will take the sum of the ages. Suppose I'm taking this age. Okay. Okay. So this is a no cycle formation is there. But here the all nodes are there. 1, 2, 3, 4. So this is a kind of tree. What else I can draw? I can draw like this also. This. Okay. This is also a not cyclic formation. There is no cycle formation inside, but the all nodes are there. Okay, or you can say that there are different formations also. Suppose I am taking like this 1, 2, 3, 4. Okay, this is also a kind of tree. Okay, so it means that tree is basically a part of that graph which don't have any cyclic formation, but also the all the nodes will be a part of that subgraph or tree. Okay, this is the most important part you have to keep in mind. Okay. Any doubt in this?
No, sir.
Okay. And also this tree is a subgraph. This it is already written in the definition itself. This tree is a subgraph, means it's a part of the graph. It is not containing all the edges, all the nodes of that graph, but it is containing few means all the nodes, but few of the branches. So it is a kind of part of that graph. So it is called as subgraph basically. So, and also it connects all the nodes without forming a closed loop, which I have said that there is a no cyclic formation inside of that. And also there is a one important part. Okay. If there are n nodes are there, the rank of tree will be n minus 1. This you have to remember. Okay? Because if you see, suppose I am taking this as a graph, suppose this is as a tree. So what are the branches being left? So these are the one branch, this was the one branch, and this was the one branch which was left. Okay. So, and what was the original structure or original node formation was there? Suppose there are one, two, three, four nodes were there. So number of nodes were how many number of nodes were there? There are four nodes. Okay. What is saying that you can form a tree with the rank which is n minus 1 times of that. It means that the number of branches of a tree will be n minus 1. N is the 4. 4 minus 1, which is equal to 3. So in the each tree, if you see how many branches are there. So if you see here, there are one branch, two branch, and three branch. In also this tree, this is the first. Suppose in the second tree, if you see one, two, three branches are there. In the third tree, if you see one, two, three branches are there. So it means that if you have the four nodes, you can make the tree with the three branches. Okay, that is the n minus one number of branches. So just this you have to remember that if there are n nodes in a graph, so the tree will be found with the number of branches that is equal to n minus one. Okay, so let me take one example, means question basically. So if you have considered studies this, what is the branches, what is the nodes? So this is the one question related to that. So there are, suppose there are n nodes and there are b branches are there. So you have to find out what is the number of links with respect to choice of a tree.
Sir, your screen is not visible, sir.
Yeah, can you repeat that?
Your screen is not visible, sir.
Screen is not visible.
Ah, now it's visible.
Okay, I think your internet problem is there. Okay, if you feel any doubt, means whatever whenever the screen is not visible, just let me know. Okay. So this is the graph. Suppose there is a one graph which where the number of nodes are there. Number of nodes are n. Number of branches are b. You have to find out the number of links. Okay. Take with the example. Suppose this is a one graph which I am giving. Node 1, node 2, node 3, node 4. This is the A, B, C, D, E, F. Try to find it out which equations can be correct. Okay, with the definition of the links which I have given. Okay, try to find it out. After that, I will give the solution. Take your time and think what could be the exact solution for this. Take your time in thinking. Okay, I got answer as option one. Okay. Others, take your time to think. Okay, there's no need to rush into the answer part. Just think why is first option is correct, why is the second option is not correct. So think in that manner. Okay.
Here, what is links?
Okay, let me give the definition of thing. Node, you remember, no? What is the node? Node is basically the
Yes, sir.
okay. So let me give you the definition of the link. After that, you can solve it. So if you see here, the link basically, no? So if you see the link definition, the connection between the two nodes, it can be directed or unidirected. Means connection between the two nodes is called as basically the link. Okay. So it can be directed or it can be non-directed also. Okay. Getting my point. So that is a concept of link.
That's eczema, sir.
Okay. So there is a difference between the edges and the difference between the links. Okay. Edges are the part of the graph. Okay. But the links can be different. Links can be part of the subgraph as well. So their means numbers cannot be equal in all sense. Okay. So the branches will be a part of the graph where suppose this graph which we have taken, there are six branches are there. Okay. But the links can be different in a tree, which can here it is being asked with respect to the choice of tree, because trees are the subgraph, so part of a graph that is a part of the subgraph. So in that sense, you have to see what the number of links will be there in that tree. Okay, that is different from the branches. Getting my point? Think again. After 1 minute, I will give the solution. Okay. Okay, let me give the solution for this. Okay, after that you can think of. So here what I have told that the number of nodes are n, number of branches are b. So it is being asked that what is the number of links? Okay, so links by the basic definition is that it is the edges basically. It's a part of the subgraph or a graph, and it is the link between the two nodes basically. Okay. What I have told that how many number of branches are there? How many number of branches? So let me remove this. So number
Six.
of uh, are you saying something?
Six branches are there, sir.
Yeah, there are six branches are there. Okay, but what are the number of branches for a tree? Number of branches of a tree that I have told that it is n minus one basically. So it's a whatever you having the nodes, so the branches of a tree will be the n minus 1. Okay. And also the thing is, what are the number of branches, basically the total amount. They are actually equal to the B. Okay. The third thing is that number of links is equal to number of edges or number of branches inside of the core tree. Inside of core tree. What is core tree? Core tree means The tree which you have already formed, suppose I have formed a tree here like this, so it don't have any closed path and the edges are like this, A, B, C, D and 1, 2, 3, 4. Okay. What is being left? So left part is like this. So this is the dotted part which branches are being left off. So when you draw this again, that is a lift part. This will be made like this. Okay, kind of. Okay. So what are the branches here? C, F, and B here, and these are the nodes 1, 2, 3, 4. Okay. So this is the core tree. Okay, and this is the tree. So whatever the number of branches being left when you form a subgraph out of that, that is called as a core tree. And number of branches of that, because total branches were B and the tree is having the number of branches as n minus 1. So the number of branches of a core tree will be equal to B minus n minus 1. That will be equal to B minus n plus 1, basically. Okay. So the first option is the correct option. Okay. Any doubt? Any doubt in this? Okay, let's move to the next problem. That is also an important question. Try to solve this. Proper tree means simply the tree definition. Okay. You have to tell me that which option is correct. If you are forming a tree out of this graph, take your time and solve it. Go with the basic definition. First is that you don't have to form any cycle or the closed loop. Second part is that all nodes will be connected in that particular tree. Means all node be a part of that. And A, B, B, C, A, D here is the branches of that particular tree.
Option 1 and 3.
Option 1 and 3. Okay. So I got one answer at option 1 and 3. Let's wait for one more minute. After that, I will use the solution. And again, cross verify the answer whether it is correct or not. Okay, I got one more answer there, except two, all the correct answer means one, two, four, one, three, four, basically. So let me give the answer for that. If what is the basic criteria of the tree? What I have told that there will be no cycle will be formed. Cycle means no cycle will be formed, means there will be no closed loop. Second is that all nodes be a part of tree. All nodes be a part of tree. Okay. So let's go with the option first. Option first is saying the AB, BC and AD. AB, BC and AD. Okay. So this is actually A, B, C and D. So that these two criteria, that no cycle formation and that all nodes be a part of that tree is satisfying. So first option is correct. Okay. Let's go to the second option. It is saying AB, that is the AB and BC and also CA. CA is like this. Okay. So this is A, B, C. So now here the cyclic formation is there. Okay. So this is a not a tree. Okay. So the second option is not correct. So let's see the option 3. Option 3 is that AB, BD and CD. If you see that like this, CD will be like this. So this is A, B, C and D. Oh, sorry. This is C and this is D. Okay. AB, BD and CD. Okay. So this is the tree basically because there is no cyclic formation. The all nodes are part of this. Okay. So third option is correct. Let's see the option 4. Option 4 is that AC, AC is like this and the BD, BD is like this means A, B, C and D, BD like this and AD, AD is like this. So this if you can see, this is also not a closed path and also the all nodes is the part of that subgraph. So this is the also A means AC basically and BD, BD like this and AD. Okay, so the option 4 is also correct. So the second option is not correct because there is a cyclic formation, but the other options that 1, 3, 4 is all correct. Okay. So they are actually making a tree. Okay. That is the AB, AC here, and the BD and AD. Okay. I hope you have got the sense how to see that whether it is a tree or not. So let's try to solve one more question on that. Try to solve this. Let me know which is actually the graph is a kind of tree. So this is actually the graph.
Option B.
Option B, you have to tell me that which is a not a tree.
D, sir. Option D.
Okay, option D. So this is actually the graph. Okay, if you see here also the all nodes are connected. Here also all nodes are connected. Here also all nodes are connected. In this, if you see the one node is not connected and also one cycle is being formed. So this is a not a tree. Okay. So the A, B, C is actually a tree and D is not a tree. Okay. So basic definition. Let's move to the another part. Try to solve this.
What we should find, sir?
You have to tell me that that branches, suppose there is a ADEH, so these are the ADEH. So you have to tell me that which branch is actually forming a tree. Write the answer in the chat box.
Option C, sir.
Option C. Okay. I'm giving one more minute also to solve others as well. And you can verify your answer as well, whether it is correct or not. Take your time and verify that. Okay, C option, I got one more answer. So let me give the solution for this. So the basic definition of tree that criteria, there is will no cyclic formation, no cycle will be formed. And the second thing is that all nodes should be a part of that graph, subgraph basically. So let's see that the first option. If you see the ADEH, this is the A.
Sir, what's the question, sir?
Okay, question is that you have to tell me that this is the branches that ADEH, ADEH, and the including that branches, which formation is which subgraph is called can be called as a tree or not? Okay, can be called as tree basically. Okay, so there are four options are there. You have to tell me that which branch combination is making actually a tree. Okay. So I'm giving the solution. There are more questions on the tree as well. So the basic definition of the tree is that means criteria to find out that first is the no cycle will be formed, and second is that all nodes will be the part of that subgraph, part of subgraph basically. Okay. So if you see the first option, option A, when you draw the graph, that is the A basically connecting the 1 and 2, D connecting 2 and 4. If you see the E is basically connecting 2 and 5, that is the E, and also H is also a part of that, H. So in this part, if you see, there is this cyclic formation is there. One cycle is being formed, and also one node is being left, 3. So this is not a tree. Okay. Let's see the B part. B part is that A connecting the node 1 and 2, C is basically like this, A connecting 1 and node 3, this is C, F, F is basically connecting 2 and 3, this is the F, and this is the A, and if you see the H is basically connecting 4 and 5, like this, okay? So here also one cycle is being formed, and also this is not connected. Okay, the all nodes will be the part of that graph. Okay, and there must be a connection point between the nodes. Okay, so this is also not a tree. Let's see the option 3. Means option A is incorrect, option B is correct incorrect. Let's see the option C. Connection point between the 1 and 2, that is the A. F, F is between the 2 and 3, this is the AF. H is connecting point in between the 4 and 5, that is the H. And G is connecting point between the 5 and 3. Okay. If you see in this, all nodes are the part of this subgraph. 1, 2, 3, 4, and 5. And also there is no closed loop as well. So this is the graph. This is a kind of tree. Okay. So this actually satisfies the basic criteria of a tree. Let's see the options D as well. D, if you see, this is the A connecting point between the 1 and 2 node. E basically connecting point between the 2 and 5. And also F. F is the connecting point between the 2 and 3. And the G. G basically the connecting point between the 5 and 3. So here also one loop is being formed. If you can observe that this is the loop. So this is not a correct option for a tree. Okay. So the correct option is basically C only. So where there is a no loop formation is there, and all nodes is the part of that subgraph, and there is a one connection point in between the nodes. Okay. Any doubt in this?
No, sir.
Okay. So let's go to this in solving the other part. Okay. So there is a one more definition is that directed and undirected graph I have already told in between the nodes. Suppose this is the graph. Suppose this is the graph. The current direction will be given. Means connection means how the branches is being there and how the current is being flowed in that. So this is suppose one, two, three, four nodes are there. So this is a kind of directed graph. And if the direction is not given, there is the undirected graph. And the other one more thing is that planar and non-planar. Okay. So the planar means if you have the two connection point between the nodes, or means if you can see that if the no two branches of the graph crosses each other, means suppose this is the one branch and another branch is we have kept it like this. Okay, so here the one connection point means cutting point is coming in between the two branches. Suppose this is A and this is B. So this is not a planar. It means that it is a 3D structure basically. Okay, it is not coming into the XY plane. So that cannot be considered as a planar structure. They will be considered as a non-planar. We have the one question. After that, we will see that why how it is called as a planar or how it is non-planar. And means basic definition of the planar and non-planar is that if there is a no two branches of a graph basically cross each other, then it is called as a planar structure. Okay. So let me give the one example. Suppose there is a one example like this, and I have to find it out whether it is a planar or non-planar structure. If you see here in this question, this first part means first graph can be drawn like this as well. Yeah,
And the previous question, if no two branches of the graph cross each other,
yeah,
but you have the diagram you have shown this is here the two branches are the crossover, right, sir?
yeah. So this is a not a planar structure.
Oh, non-planar graph, right, sir?
Yeah, that is a non-planar.
Okay, directed means the current direction. If it is there, then
Yeah,
like that.
yeah, yeah.
Undirected means there is no current direction.
Yeah, suppose I take the one example. Suppose like this. This is a graph, and there is a no current direction is being shown in the branches. So this is the undirected graph. Okay.
Okay, sir.
Okay. So let me take the example. Suppose I am taking the first part. So let's draw the graph of this. Suppose I am drawing the graph of this first. One, two, three, like this, four, like this, and one structure is like this. Okay. So let's me give the nodes one, two, three, four. Okay, so this graph can be drawn like this as well. If you see that, suppose this is branch A, B, C, D, E, F. So the F is like this in between the one, two, three, four, A, D, E. So the B branch can be like this, and the C branch can be made like this as well. Okay, so this is the C branch, where there is a no crossing is there. Here also the one crossover is there, but it can be drawn like this as well, outside. That is not affecting the overall structure of that graph. Okay. So this is the consider as the planar structure, which can be drawn in form of the planar format, which can be drawn in the XY plane basically. If you see the second option, that is option 2. Here also you can draw this register outside as well, like this, connecting between the nodes. And also this structure also outside of that node. Okay. So this is a considered as a planar network, basically. If you see the option 3, if you wanted to make out of this register, you cannot do it because it is connected here. If you wanted to take it out, Here also you can connect it, and also you can connect it like this, here like this. Okay, this is a kind of planar structure, but you cannot reconnect this register because it is coming in between the two. Okay, are you getting my point? What could be called as a planar, what could not be called as a
Yes.
non-planar. Okay, so these are the basic definition. I just wanted to give you a glimpse of the planar and non-planar structure because it's a part of the graph theory. Okay, you don't have to go into the depth of that. Just remember that there will should not be any crossover, and also you can redraw the structure if taking that branch out of that graph. Okay, so let me give one easy problem.
Sir, only that circuit, only three is planar, sir.
And no, here the two options are correct. You can solve it at your home and try to see by yourself whether it is a planar or not. Okay. I know the answer, I can give it, but try to solve it by yourself. Okay. The correct answer is 1 and 2. Basically, 1 and 2 is a planar, 3 and 4 is not. Visualize it at your home so you will get the glimpse of that, whether it is planar or not. Okay. So let me give you an easier problem of this planar and non-planar. You can give the feel. Try to solve this. And don't draw it, just observe the graph. And if it could be drawn outside of that means crossover, then it is called as a planar. If it is not, then it is non-planar.
Option B, sir.
Option B, fourth only. Okay. Others, take your time to solve. Okay. There's no need to rush the answer, going to the rushing towards the answer part. Just observe the graph and then give the final answer.
Sir, in the 2 there is no crossover,
Okay. Yeah.
and
That.
in 3 there is no crossover. I mean,
Yeah.
I'm telling that the second diagram, sir. Second diagram there is no crossover.
Yeah.
Third diagram also there is no crossover.
Yeah. That is correct. That is correct. Means second and third and the first don't have any crossover, and the fourth has. Okay. Let me go towards the definition and then see the what is the correct answer. Let me move by step by step. Suppose this branch, if you see, this branch is there. I can redraw it like this as well. Okay. So the basic means the meaning of that branch will not be lost. Okay. So this can be drawn it like this. So it can be considered as a planar. Why? Because there is no crossover. You can connect it like this. You have connected like this, connected like this. There's connected like this. Okay. So this is a kind of planar structure you can represent in the 2D format. In the second also, you can draw this branch like this. Okay, like this you can draw it outside. Okay, so this is also a kind of planar structure. What about the first part? If you see this branch, you can draw it outside as well. Okay, like this node here and not like node here. And this branch you can also draw it outside without affecting the property of it, like this. Okay, so this is a kind of planar structure. But the fourth, if you see, you cannot draw it outside. Suppose this branch I wanted to draw it outside. If you wanted to draw it also, you can crossover. There is a one crossover here as well. Okay. If you wanted to draw it outside this branch, okay. So here, if you there will be one crossover. Okay. So the fourth is not a planar structure. It's a kind of non-planar structure. So the option B is actually correct. Okay. Any doubt? Okay. Let's move to the next question. Try to solve this.
Option 2, sir.
Option two. Okay. Okay, I got one more option answer as the option two. Okay, so the all have given that this option two. That is correct actually. So from the basic definition itself, that key all nodes should be the part of that subgraph. Okay, subgraph, and also if there are n nodes, the tree will have n minus one branches. That is also correct. But there will be no closed loop formation. So this is option is correct. So correct option is actually option two. Okay. So let me go to the some other definitions as well. Let me go to the twig and core tree. Core tree I have already explained, that is the remaining part of that graph other than the tree is a core tree. Okay. And second thing is that the twig. Twig is basically the branch of the tree is called twig, which is indicated by the thick line. Any tree with n nodes and n minus one twig basically. And the twig is actually the connected subgraph that includes one or more leaf nodes. So the basic definition is that of the twig is actually the branch of that core tree. Okay. So suppose this is the core tree. If you see here, this is the core tree with something branches 1, 3, 4 and all. So this is actually core tree which is having the branches C, A, F. Okay. So this is the connecting point between the two nodes that will be called as a twig basically. Okay, sorry, this is a part of a tree basically. This is not a co-tree. Okay, so the branches of a tree is called a twig. Sorry for the connection here. So the branches of a tree is called as a twig. Remember like this, the tree and this is twig. Twig means the branches of that tree. And the core tree is the remaining part of that subgraph graph other than the tree is a core tree. Okay, any doubt? The branches of a tree is twig, called as a twig, and the remaining part of the graph other than the tree is a co-tree.
So the branches of a tree is called a twig.
Yeah, that is correct. It is a branch of a tree. Suppose this is a tree and there are the branches A, B, C. So the twigs are A, B, C basically. Okay. And
Ah, yes, but in this you have shown that it's a closed loop poetry.
no, so this is a co-tree.
A poetry and a this tree both are actually poetry. Is it a closed loop, sir?
Yeah, it can be. It can be. Suppose I am taking one example. Suppose I am taking one example like this. Suppose this is a graph, okay? And nodes are 1, 2, 3, 4, okay? And the branches are A, B, C, D, E, and F, okay? And I wanted to draw a tree basically. So let's me draw a tree. Tree means connecting point, means all nodes should be a part of that subgraph and there not be any closed loop. Suppose I draw like this. Okay, this could be a tree A, B, C, and all nodes are connected 1, 2, 3, and 4. So what are the remaining part? Remaining part is like this. Remaining part is like this. Okay, so this is actually the remaining part is called as a twig. It can be a closed path. So let me take the another pen for this. So the what are the remaining part? Remaining part is like this. Okay, like this. So what are the branches? F, E, D, and this is the 1, 2, 3. 1, 3, and 4. If you see here, there the nodes are not equal to the graph, and also there are the closed path as well. So the core tree don't have any definition. Okay, means whether it is a closed path, whether could not be any closed path. Just remember like this: in a graph, when you form a tree, whatever is being left is a core tree. Getting my point?
Yes. Yeah,
Okay.
understand, sir. But for a tree, there should be no closed loop,
Y-
right, sir?
Yeah, exactly.
But for the core tree, there may be a closed loop.
Yeah, that is true. That is true. Okay. So this is the basic definition of the tree and the core tree and the twig. Let me solve one problem based upon this. Try to solve this problem. So there is a one graph is given and you have to see what are the correct number of nodes, branches, twigs and the links. You can give the two options as well. So I will say that whether in between the two options which is correct. If you're not getting the correct answer fully, so you can partially give the answer that these two options can be correct.
Option B, sir.
Okay, I got one answer, option B. Let others also saw. Okay, I got one more answer as a option B. Okay, take your time. There's no need of rushing towards the answer. And those who have given the answer, try to re-verify the answers. Okay, let me give the solution for this. I have got the B option as the most priority answer. Let me solve this. Okay, if you see in this graph, there are four nodes. One node, second node, third node, and fourth node. Okay, so the this A and B, this C,
So that the intersection, we can't call it as node. Also.
no, no, you cannot consider that intersection point. If it is an intersection point, then the bubble will be more made like this. So if you see here, this is a node because it is highlighted with a pointed points. Okay. So, but that is not case with the intersecting point. So that's why you cannot consider it as a node. Okay. This all nodes are represented if you see that the here. So they are being represented with the dotted means bubble, which is actually the means a higher radius. Okay, it is if you see here the intersection point, it is not being made like that. So that is not node. If it is there, so it will be highlighted. Okay, and the graph is actually being made of means these analysis possible for the planar networks only. If it is a non-plane network, it will be a difficult to find out the values. Okay, getting my point.
So for
So
non-planar, it will be a node as a that
mm,
interconnect.
no. Okay, so don't go into the planar and non-planar structures. That is more difficult part, and that will not come in the gate also in your numerical. Just remember the definition of the planar and non-planar. That's more than enough. Okay, if it could be a dotted point here, so it is a planar network. Okay, so means non-planar structure because it is a intersection point between the two nodes. That's why it is don't have any intersection point, so that is called as a non means planar structure. You can redraw it also like this. So it could be found as a planar network. Okay, planar graph. Okay, so there are four
Oh,
nodes. So there are four nodes here. So one, two, three, and four. Okay. So the option A and option B can be correct, and option C and option D are not the option. Okay. What about the branches? Branches, if you see in between the nodes, so let me take another color. So if you see here, so this one, two, 3, that is the 1, 2, 3, and this is the 1, 4, and this is the 5, and here that is the 6. So there are 6 branches. So all A and B options are means both having the 6 branches. What about the twig? Twig, I have told that twig is actually a branch of a number of branch of a means branch of a tree. Okay, and the number of branches of a tree, there is one formula I have given. Number of branches of a tree is equal to n minus 1, where n is the number of nodes, basically. So here the number of nodes is 4, that will be equal to 3. Okay? So the number of twigs is the same as the number of is the number of branches of a tree, which is equal to the n minus 1. That is the number of nodes. Whatever the number of nodes are there, minus 1 is actually the number of twigs. Okay. So this C option is there, 3. So that is means option B is actually correct. So let me see about the link. Okay. So there is one query. Sir, 4 and 5 are redundant. We should still consider both. No, this is not redundant. Redundant means if you see the 5 and 6, you can redraw it. Okay, are you getting my point? 5 could be drawn like this as well. Okay, this is the 5 branch if you are not considering this. So this is not a redundant. Are you getting my point? So this is not redundant. So there could be a one register here, one register could be here. So that register is being made like that. So two parallel resistances, or there could be one capacitances also. So that's why that is not redundant. Okay, redundancy don't affect the things. Okay, here. Okay, so this is the number of branches of a tree, that is twig is equal to n minus 1. What about this link? Link, I have told that it is actually the number of branches of a core tree, which is equal to total number of branches minus the number of branches of a tree. What is the equal to L? What is the number of branches? That is equal to the 6 from here. And what is the number of nodes? That is equal to the 4. When you put the answer, you will get 6 minus 3, which is equal to the 3. Okay, so the B option is actually correct. Any doubt in this?
No, sir.
Simple formulas are there, so you just have to remember that what is the actual definition of the particular component. What is the twig? What is actually the link? Link is basically the branches of a core tree, which will be equal to total number of branches minus the number of branches of a tree. Okay, so let me move to the another question. Try to solve this. Simple problem, basic definition. Option C, one got. Re-verify the answer. If you have got the correct answer, try to check whether it is correct or not. Number of links means number of branches of that code tree.
Option A, sir.
Okay, option A. I've got the two answer of the option A. Okay, that is a simple problem. That link formula, that a number of branches of a code tree is equal to L, that is equal to B minus N minus 1. B is the total number of branches, N minus 1 is the branches of a tree, which is equal to B here it is given 4 minus N minus 1, 3 minus 1, it is given already. So it will be equal to 2. Okay. So the links of a code tree means the branches of a code tree is equal to B minus N minus 1. Okay. So that is equal to 2. Try to solve this. Okay, 4. That is, I got one answer as the option D, 4.
Option D.
Okay. That is actually correct. Okay. The no what is the tree? Basic definition. That is the number of branches of a tree. Okay. So that is actually the number of branches of a tree. Branches of a tree. Okay. So that I have already told that will be equal to n minus 1. Here the what is n? N is 5. 5 minus 1 that is equal to the 4. Okay. So the here till here it is the basic definition problems. Let me jump to the very important part, that is the link or the chord. Link or the chord, you have already seen that what is the link and uh, which I have already told. So here the important point is the definition, that is the edges that connect the two non-adjacent nodes in a graph, creating a cycle if added to a tree. This concept is used in network optimization. You don't have to remember this, just remember that what is the link or chord. It is actually branches of a code tree. Okay, that will be equal to b minus n minus 1. Okay, important part is the degree of a node. Okay, suppose I take the one graph like this. Suppose this is a graph, okay, and there are 1, 2, 3, 4 nodes are there, okay. So the degree is the number of branches is connected to that node is the degree. What is the degree of node 1? It is 3, okay. So why? Because there are 3 branches which are connecting to that node, okay. So the if you see the degree of node 1 is 3. What about the node 2? Node 2 is also connected to 3 branches, so its node is degree is 3. What about the node 3? It is also connected to the 3 branches, so the of that 3 also it is 3. If you see the node 4, it is also connected to a 3 branches, so the degree of the 4 is also 3. Okay? So the degree is the connection point of that particular node. How means number of branches connecting to that node is called as the degree of that particular node. Okay? Any doubt in the degree?
No,
Okay, let's solve this problem. Find it out the number of chord in this. Number of chord means you have already seen what is the number of chords, basically number of links. After that, we will see the matrices, that is incidence matrix, cut set, tie set. We will go with the basics and see how to form that matrices. Okay, I got one answer, option 4, means option 1.
three.
3. Okay. Okay, that is actually a simple problem. Steps are like that. You have to make a graph out of that. Suppose I'm considering this. These are the nodes. Okay, answer is 5. One answer I've got the 5. Suppose this is the nodes. Basically, they're greater than 2 elements are connected. So that's why it is called as a node. Okay. So node, if you see the nodes 1, 2, 3, and here it is 4. So making a graph out of that 1, 2, 3, 4. So these are the connection points, and this is actually the graph. Okay. So this is actually a graph of this network. Okay. If you see the number of nodes here, what is the actually the definition of the number of chords? Number of chords is the number of the links. Number of links is equal to b minus n minus 1 basically. Okay. How many number of branches here? If you see the number of branches, 1, 2, 3, 4, 5, 6. So there are 6 branches are there. How many number of nodes are there? 1, 2, 3, 4. 4 nodes are there. So that is equal to 4 minus 1. What is equal to that? It is actual to 3. Okay. So the what they answer given by one of the student that it is equal to 5. 5 is not the correct answer because that is the number of branches of a tree. That is the twig. Twig is equal to n minus 1. Okay. So when you're finding number of links or number of chords, that is equal to the number of branches of a chord tree. Okay. That is equal to b minus n minus 1. Okay. So let me go to the one major important part. This I have already explained. What is the subgraph? What is a connected graph? What is a directed graph? You can read it out at your home. So let's say most important part is the cut set matrix. Cut set matrix is basically most important.
Sir, sir,
Yeah.
please go to the previous slide, sir. Subgraph.
Okay. Subgraph.
Yeah.
Subgraph is basically a part of a graph. Means suppose there is a one graph is there here like this. One graph is there. Okay. So the subgraph can be formed like this. So the suppose I'm taking few of the branches. Suppose I've taken this branch. Okay. So this is a kind of subgraph. Okay. Subgraph is a part of the graph, but with the with not having the equal number of nodes or equal number of branches. Okay. But it is a part of that. It is being formed from that graph itself. So that is why it is called as a subgraph. Okay. At least one path for each node to every other nodes. Okay. So here also if you see the each path having the nodes connecting path between the nodes at least one. You can have the two as well. Okay. So that is a called means a tree is also a part of it. It can be called as a subgraph. I hope you have got the answer.
I understand.
Okay. So let me go with the most important part that is the cut set matrix. Okay. So cut set matrix is actually very, very important part and how to form it. Okay. So link and twig definition we have already seen that link is actually a part means branches of a core tree and what is the twig? Twig is the branches of a tree. Okay. How to form the cut set matrices basically. Okay. Let's move with that. So, few things I will say that you have to just remember it. Okay. Suppose I am taking one example of a fundamental cut set. Okay. That is a basic form of the cut set matrix. Okay. Fundamental in the fundamental cut set, there will be remember this. Okay. There will be one twig and rest link. Okay. Getting my point. There will be only one twig and the rest is the link. Okay, I will give the detailed way. Just remember this that there will be one tweak and the rest will be the link. Okay, let's me give go to the fundamentals of that. Okay, see here. Okay, suppose this is a oriented graph or the directed graph that is actually the same. So if you see the nodes here, node A, node B, node C, node D. Okay. So this is a oriented graph, and where the direction of the means orientation of that particular branch is given. Okay, that is a 1, 3, 1, 2, 3, 4, 5 basically. And after that, you have to form a tree. Okay, suppose I have formed a tree like this. So connecting the means second branch, fourth branch, and the third branch. Okay, so the here what is here twig. So let me take another color. So here the 2, 4, 5 is actually a twig because it's a part of the branch of a tree. What about the 1, 5? So it is actually a link. Getting my point? So the branches of a tree is a
Five is it, sir? 2, 4, 3, right, sir?
because you can take anything. You can take the other graph as well. Suppose I'm taking making like this 1, 3, and
No,
4.
no, sir. That solid lines only we have considered as a tricks, right, sir?
Yeah,
Or
yeah,
okay.
that's true. So that is actually a part of the tree. Basically, the solid lines is actually a tree, and the non-solid lines, though that is the dash lines, is actually representing core tree. Okay, so that is the basic methodology to represent a tree and the core tree. Tree means solid line. Core tree is a dotted line, dashed line. Okay, so that's why the 1 and 5 branches are actually a link, and the 2, 4, 5 is a twig. Okay. When you see that, if you take the branches, suppose I'm taking the first branch, what is the fundamental cut set which is being told? Fundamental cut set is that there will be only one twig, which I have told here. There will be only one twig and rest link. So you have to go to the each node and check whether it is connected to a one twig and the any number of links. Okay, that where you can form the cut set. Let me jump to the node A. Suppose I am going to the node A. Here, if you see, there is only one twig. One twig is the 2. Okay, so here is the dotted line 1. 1 is the link basically. So there is the definition is actually matching. There is a only one twig and one link. Okay, so the cut set will be formed here at A. What is the meaning of cut set? Cut set is basically you can form a subgraph out of that. The cutting from a graph in for making it a subgraph is a basically a cut set. Okay, cutting from a graph to form a subgraph is a called as a cut set basically, where you can form the cut set or where you cannot form a cut set. So at a node A, the basic definition is matching. There is only one twig and one link. So you can form a cut set here. But if you see the node B here, there is not no any, there are two actually, one here, two here, three here. There are three twigs, but there is a no link. Okay, so the basic definition is that there should be only one twig. Okay, you cannot form a cut set at a B, fundamental cut set at a point B, at node B. Okay, but if you see the node here, node C, there is a one twig and one link. Okay, the 5 is the link and the 4 is actually the twig. So you can form the cut set at C. What about the here D? If you see the D here, here there is a only one twig. Okay, this is the twig basically, and there the dotted line, there are two dotted line. So the definition is matching. There is a only one twig and there is a two links. Okay, so you can form a cut set. So in this graph, in this tree, how many cut set can be formed? Cut set can be formed here at A. B you cannot form. Fundamental cut set. C you can form. D you can form. Okay, there are three cut sets which is possible in this tree. Okay. Second thing. Second, what is the orientation of that cut set? The orientation. Suppose this is the orientation is the cut set. So the cut set orientation will be same as the direction of the twig. Okay, suppose in this, if you see the twig direction is like this. So the basic here, the direction of the cut set will be like this. Okay, what about at C? C, if you see the cut set here, that it is coming like this. Okay, the twig direction. So the cut set direction will be like this. What about at D? D, if you see the cut set, it is coming like this. So the cut set direction will be the like this. Getting my point? So the how to form a cut set? Cut set, you have to take a graph, then form a tree, and at a particular node of that tree, check whether only one twig will be there and any number of links can be there. So that is actually a basic definition of the cut set matrix. Okay, let me take example. Okay, so the what is actually the cut set matrix? That is most important. So cut set 1, 2, and 3 is formed. So cut set 1, 2, and 3 means one here at node A, one here at node C, and one here at node 3. Okay, so there are three cut set which is being possible. So now the thing is how to form a cut set matrix. Write it like this: cut set C1, C2, C3, three cut set, and write the branches here. One means basically the 1, 2, 3, 4, 5 branches are there. Because if you see here in the graph, there are 5 branches: 1, 2, 3, 4, 5. In the horizontal, in the column, you write the number of branches like this: 1, 2, 3, 4, 5. And in the horizontal, in the row wise, write C1, C2, C3. Okay. Now go into the graph. Okay. Suppose this is the cut set. This is the first cut set. That is the first. In this, if you can see, orientation, what I have told, that will be similar to the twig. Okay. Here the orientation is like this, so the direction will be like this. Okay. So whatever in the direction of that will be considered as the plus one. And if it is not there, suppose the branch is not included in that, it is zero. If it is a opposite direction, it will be considered as a minus one. Okay. So let's see the cut set one. Any point if you feel the doubt, just let me know. Okay. Suppose I am taking the cut set one, C1 here. So this is the simply the cut set here, C1. This is the cut set C1. Okay. How many branches are actually included in that cut set? Two, 1 and 2. If you see in the column itself, okay, it can be different based upon the how the branches. Here they have considered the two branch here, fourth branch here, three branch here, one branch here, and the five branch here. So it's based upon the representation how you are representing. Okay. Suppose this is the plus means cut set one. So the first branch is actually minus one. Minus one. Why minus one? Because the what is the direction we have considered? Similar to the twig. So it is the direction like this. But if you see the branch direction, it is opposite. So that's why it is taken as minus one. What about the branch two? Branch two, if you see, it's a plus one because it's in the same direction of that cut set. So that's why it is taken as the plus one. Others are not connected, so that's why it is taken as a zero. Okay. Any doubt in this cut set? If you are having any doubt, just let me know. So the basic methodology is form a tree. Okay. Form a tree. Go to the nodes, check whether the only one twig and the number any number of links can be there. What is the direction of that cut set? It is a similar to the twig direction. And then if it is in the same direction, the branch current, take it as a positive one. If it is in the opposite direction, take it as a minus one. If the no branch, other branch is not connected, take it as a zero. Okay. So the for C1 I have given. Try to find it for the C2 and C3 at home. Okay, I will save the slide. Try to find it out and make the yourself the cut set matrix. Okay, it's for the C2 and C3. Okay, any doubt?
Not.
Okay, so let me move to the incidence matrix. Incidence matrix I have already explained in the last class. This is the row and this is the column. The column is actually the branches and the rows are the nodes basically. So you just have to write the nodes in the horizontal manner that 1, 2, 3, 4, how many, however the number of nodes are there in the graph. So this is the graph. There are four nodes are there. Write it like this, 1, 2, 3, 4. And in the column, write the branches. Okay, A, B, C, D, E. And go to the particular node and check whether the how the directions are there. Suppose it is out of that node, it will be considered as a positive. Okay. Suppose I have jumped to the node 1. How many branches are connected? Branch A connected, branch F is connected, branch C is connected. Okay. And so that's why if you see in the column as well. So where it is non-zero terms are there. Non-zero terms is here A at C and F. There are non-zero terms are there. Others which is not connected, write it as zero. If it is out of that network node, consider it as a positive one. Okay. So it is a positive one, positive one, positive one because it is going out of that node. Okay. Let's take the node 2. Suppose I'm taking node 2 here. Here, if you see the current is coming at from the node 1 to node 2 at a branch A, B, D. So branch, how many branches are connected? A, B, and D. Okay. So the non-zero terms are there A, B, D. Okay. And also it is coming into the network. Okay. A, B, D, A, B, D. Here it is given wrong. So if it is B is actually coming into the network, it is minus one. D is going out of that node, so it will be positive. Okay. So this is the basic method to solve the means form incidence matrix. Incidence means how the incidence of the current is there at a particular node. What is the rows? Rows are the nodes. What is the column? Column are the branches. You have to just see that orientation of a particular branch current at a particular node is actually incidence matrix. Any doubt in this? Any doubt? And also an important point in this uh, means in this kind of formation of the incidence matrix, if you sum up the number of means the sum the number of sum the columns, so it will come out to be. So let me take here. If you sum the number means sum the column, it will come out to be always zero. Okay. Sum the columns here as well. It is also coming zero. If you sum the column of the C, it is also coming zero. When you sum the column of D, it is also coming zero. E is also zero. F is also zero. Okay. So remember that summation of the columns in an incidence matrix is zero. Okay. That why it is?
Sir,
Yeah.
sir, is this applicable only for this matrix or this is applicable for the previous matrix also, sir?
Any
You,
any the process will be similar. You can have any kind of matrices.
no, sir, you are telling that the sum of the columns
Any
of
any any kind of matrix, any kind of incidence matrix, the summation of the column will be always zero. This is because the whatever the current is coming into that particular node will be also leaving that node. Okay. So if it is coming, whatever the coming, it also have to be synced. So that's why at a particular branches, so the plus one minus one will be there. So that's why it is actually coming zero. So let me take one question that will be more clarify you. So take this. If you see, there are four options are there. So the first option is saying the rows of incidence matrix A represent the number of branches and the column matrix usually represents the number of nodes. What is saying that? Suppose you have an incidence matrix. It is saying the rows, number of branches A. This is the suppose this is the row. It will represent the branch. Okay. And the column will represent the node. That is actually not true because we have seen here the rows are actually nodes and the column is actually the branches. Okay. So from the fundamental definition or formation of this incidence matrix is actually a false. So the first option is not correct. Let me see the second option. It is saying the algebraic sum of elements of all the columns is zero. That is actually true. From the matrix itself, we have seen that summation of the column, particular column, is actually zero. Okay. If you see the options three, it is saying the rank of incidence matrix is n minus one. Okay. I hope you have studied the mathematics, the engineering mathematics, the rank and the other parts. So basically the why it is n minus one. When you have the suppose you have the 1 minus 1 0 0 kind of matrix. Suppose I'm taking a 4 cross 4 matrix here. 0 minus 1 1 0 0 0 minus 1 1 0 minus 1 1 0. Okay. So this is a kind of incidence matrix A. From the road means rank definition, you can this 0, this C4, column 4 and the means first fourth row and the first column, that is C41, can be equal to C4, okay, C first column first element plus C12 plus C13 plus C14. Okay, you can represent it of a particular column with the summation of that elements as well. Okay, that's why it can be said that this is the 1, this is 0, this is 0, this is 0, minus 1, minus 1, 0, minus 1 of this matrix. That is similarly which I am representing, that is rows. That is the 0, 1, minus 1, 0. And the another, that is last part, last column, it will be equal to 0. Why? because the summation of the particular column is usually 0. So that's why its rank became the n minus 1. Okay, getting my point? Because the one column, one row is particularly 0. So that's why there is rank is actually equal to the n minus 1. If you see the fourth option, the determinant of an incident matrix of a closed loop is equal to unity. That is false. Why? Because the summation of the particular column is actually 0. So that's why the determinant when you form of that particular matrix is will be 0. If you see this also, this matrix, the summation of that particular row became 0. So that's why the determinant will be equal to 0. The force is also false. Okay. So the second and third option will be the correct. So what you have learned in the incidence matrix, the summation of the column will be equal to 0. Second thing, that the means incidence matrix, the rows will be equal to nodes and the column will be the branches. Third thing, rank will be equal to n minus 1. Fourth thing is that determinant will be equal to 0. Okay. Try to solve it at the home as well and try to find out whether it is coming exactly column is equal to 0 or not. Okay. Remember this. This is the most important part. Okay. I am giving you one problem based upon this. If you have any doubt in this, if you have any doubt, just let me know. Okay. I am giving you one problem to solve on this incidence matrix. So this is the incidence matrix here given. This is the incidence matrix. You have to find it out which graph this incidence matrix is there. Take your time to solve and just let me know.
Sir, please zoom it, sir.
Okay, let me zoom it. So let me write it as so that will be more clarity. Okay, suppose this is a 1, 2, 3, 4. Four nodes are there, and this is the plus 1, 0, plus 1, 0, 0, plus 1. Then this is the plus minus 1. Sorry. Basically. So this is equal to minus 1, 0, plus 1, 0, 0, and here 0, plus 1, 0, 0, plus 1, minus 1. Here it is equal to 0, 0, minus 1, minus 1, minus 1, 0. Okay. And here it is A, B, C, D, E, F. Okay. Now it is clear, I think. Okay, option B, I have got one answer as option B. Okay. I request others also to solve. This is very example. What is the rows? Rows are actually the nodes. What is the column? Column is the branch. From that definition itself, you can solve this problem.
Option B.
Okay, option B. I got that answer as well. So let me see. Let me see what is the basic definition I put. Well, if you can observe that here also the summation of the column is 0. Okay, in the all the columns. Okay, so the summation in the all columns is 0. Though this is a basic definition of the incidence matrix, that is property of the incidence matrix. And also one thing is that how many number of nodes are there here? There are four rows are there, so that's why it is a four nodes. How many number of branches are there? How many number of branches are there? There are six branches because there are six columns are there. Okay, which option is actually correct? If you see the first option A, there are three nodes only. Okay, so the option A is incorrect. If you see the C option, it is also incorrect because there are three nodes are there. If you see the fourth option, D option, there are four nodes are there, but the branches here is not six. Here, how many branches are there? One, two, 3, 4, 5 branches are there. Okay, so that's why it is also not correct. What about the B option? If you see, there are four nodes. One, two, three, four nodes are there. What about the branches? One, two, three, four, five, six. So the basic definition of this, the rows are the nodes and the columns are the branches. It is actually matching with the graph to in the B option. Okay, so the B option is actually correct. Okay. So I hope you have got the sense of this uh, incidence metric and also the cut set metric. Try to solve this.
Option is
Okay, let's wait for some other also. Okay, let me give the solution. Uh, that is correct. Actually, the option A is actually correct. Why not option B? Option B is the A inverse is equal to adjoint of A divided by mod of A, basically. Okay, so the mod A is actually 0. So the A inverse will be not possible. Okay. So the B option is actually correct. C is usually actually correct because it's not a unity matrix. So this is also false. D is also false because the determinant of that matrix, incident matrix, will be 0. Okay. So let's move to the last topic. That is actually, what do you mean by the closed loop, sir? Closed loop basically, suppose this is a graph. Okay. Suppose I am considering, suppose this is one node, two node, three and four. A, B, C, D, E, F. Okay, so these are the branches. So let me consider few of the branches. Suppose I make the subgraph like this. Okay, so here one closed loop is being formed. It means that from where you have started, suppose you have started from here, when you move to the other node, from 1 to 2, and move to the 3, and you again came back to that particular node from where you have started, it's actually a closed loop of that particular graph. Okay, so this is the one loop which is being formed for a particular subgraph that is called as a loop or cycle. Okay, cycle or a loop. Have you got?
sir. In previous question,
Yeah.
how how to find that rank is n minus one? Previous question,
Okay. Here in
that
this,
property.
yeah. So in this question, the rank is basically how many non-zero rows are there. So the rank is equal to non number of basically. Let me remove this. So the rank is basically equal to number of non-zero rows of a particular matrix of a matrix. Okay. So what I have told that if you have the incidence matrix, okay, suppose let me take this incidence matrix. In this incidence matrix, if you see the column, the when the if it is a matrix, it can be represented. This, what how this is the suppose there are three cross three matrices there. So this element will be called as A11, and this will be A12, and this is A13, and this is the A21, A22, A23, A31, A32, and A33. So this is the 3 cross 3 matrix. So there is a one property in the matrix when you have the in the determinant basically means in the determinant. So suppose you have a determinant like this A11, A12, A13, A21, A22, A23, A31, A32, A33. So in this there is a one transformation. Transformation means you can represent, suppose A13 can be represented as A11 plus A12 plus A13. Oh, sorry, A21 and A23 means one particular row can be written as the summation of that all the rows of a particular that matrix or determinant. So from that definition itself, I have written that this is the A11.
So how A31 is equal to A11 plus
This
A2?
is a property. This is a property of a matrix in determinant. So you have to go through the determinant basic properties. So that's why you have to revisit that. So after that you will get the sense. So this is a property, okay? Property of a determinant. You can represent a particular row as a summation of the all the rows, okay, of that particular column. This is a basic property, okay? Are you getting? You
Yes.
go through the determinant part, you will get the means idea of that, okay? Any graph of a circuit, I have a closed loop. I think so. I got one doubt here that any graph of a circuit will have a closed loop, I think. So why are they specifically mentioning it for incidence matrix? Okay, okay. Here it is saying that okay, it is a for a closed loop, basically for a closed loop and a for the closed loop. Okay. So it's a just a way of means writing the things. Okay. This is if you are not mentioning the closed loop itself, okay, then also you will get the feel of this. Okay. Why I'm saying that? Because incidence matrix, what you are forming, there are the all the branches are there. Okay. So there itself there are closed loops are there. Okay. If there is a no closed loop, means suppose you have taken the tree itself, and it is not a forming a closed loop, then incidence matrix you cannot form. Okay. Why? Because there are no interconnecting point between the one, two nodes, two, three nodes. Okay. So that's why you cannot form the incidence matrix out of that because you have to make the all the columns will be summation will be equal to zero. Okay. That's why each node should be connected to one another. Okay. Okay. So let's move to the last part that is a tie-set matrix. In the tie-set matrix, you just have to remember that form a tree, there are steps I think I have given. I think I have given. No. So the basic thing for the formation of the tie-set matrix, you just have to make a tree. Then after that, you have to see that the orientation of that graph. Okay, let me give the definition. Suppose this I have taken one graph and where the branch currents are given. Branch current and the loop current. What is the meaning of the branch current and the loop current? Branch current, suppose there are two nodes which are connected. Suppose this is the node 1, node 2. So the in between there are one branch will be there. So that is the branch current. That is the I1. What about the loop current? Loop current will be a closed path. In the closed path, whatever is flowing, it's a loop current. Suppose here in this example, there's I1. I1 is basically flowing inside of the loop, which is connecting the one branch also, fifth branch also, sixth branch also. But what is flowing in the first first row means the first one branch, first branch is actually a branch current. Okay, so this tie-set matrix is usually give the relation between the branch current and the loop current. How it gives? Let me see. So what you have to do? So this is the matrix basically. What you have to do, you have to write the number of loops, basically what is given, I1, I2, I3. So in this graph itself, if you see, I1 I given, I2 is given, I3 is given. Okay. So you just have to write it. What are the loop currents? Okay. Then you have to write the branches. Branches. How many branches are there? One, two, three, four, five, six. So you just have to write the branches here. So these are the branches. Okay. And now you have to take the loop. Suppose I am taking the loop I1. Okay. So how the I1 is flowing? I1 is flowing like this. Okay. So this is the orientation. So if you see the branches or branch orientation of one, so the loop is being formed like this. No, so this is actually the loop of this. So it is actually being formed with the branches first, fifth, and sixth. Okay. If you see the non-zero here, first, fifth, sixth are the non-zero because that loop current is actually being formed with the branches first, fifth, and sixth. Okay. Now see the orientation of that branch current and also the orientation of the loop current. If they are similar, give it as a positive one. If it is not same, give it minus one. So see the branch one. Its direction is similar to the loop current, so we have given plus one here. If you see the this fifth branch, it is also same. That's why we have given the positive one here. What about the sixth branch? Its orientation is opposite to that. So that's why we have given minus one here. Similarly, you have to see the I2 loop current and I3 loop current. I2, suppose I am taking the I2 loop current. Suppose this is the I2 loop current. So how many branches it is touching? Second branch, fourth branch, and the fifth branch. Here, if you see the second branch, fourth branch, and the fifth branch, they are the only non-zero components. Okay. If you see the second branch current, it is actually the forward direction. So that's why it is kept as positive. What about the fourth branch? It is actually positive. Why? It is the same direction. What about the fifth? It is opposite. So that's why it is given minus one. Okay. So that's how the Tysett matrix is being formed. Okay. Any doubt in this? Any doubt? If you feel any doubt, just let me know. It's just a relation between the branch current and the loop current. Okay, if you don't have any doubt, just move, let's move to the question part. Suppose I have one branch current and loop current means relation in between because that is the Tysett matrix. You just have to let me know how many independent nodes equations can be formed. Uh, I think that is a complicated part. Okay, so let's go to the easier thing. So try to find out the how many Tysett currents are there. Try to solve this. Tysett current means loop current basically.
Three.
Three. That is actually correct. Why? Because there is only three loops can be possible here. One, two, three. So how many Tysett currents are there? Three. That is correct. So let's move to the another question. Try to solve this. How many trees and how many cut sets are possible in this? This is an important question, and this is the last question of this tutorial session. Let me know the number of trees only. Cut set, I will give the solution. Okay. How many number of trees are possible? There is a
Two.
no two. Okay. So there is no formula for making of the uh, how many number of trees. There is no formula. You have to make it and you have to see. Okay.
Sir, for the cut,
Also,
for the
Okay. Uh, can you repeat, please?
sir, for the cut set, we have to know the link.
Yeah. Yeah. You have to see that there will be only one twig and any number of links can be there. First, you have to form a tree, and then you have to see whether it at particular node only one twig will be there and any number of links can be there. Okay, let me give the solution for this, and you can try it at your home again. Okay, if you see here, what is the basic definition of a tree? Basic definition of a tree is you just have to means there is should not be any closed loop, and also each node should be connected. Okay, let me try. Let me try first. Suppose I am forming like this. Okay, here all the nodes are connected. Nodes we have connected, and also it's a not a closed path. Okay, so it will be like this. So this is the one tree, and the second tree can be formed like this. What is the daughter is a code tree basically, and this also can be formed. No, so like this you can form. Sorry, this is also not a closed path. Why? Because this is not connected point. This point is not connected. Okay, so they are the actually the planar network. So that's why it is also possible. So this is also a loop, means tree, and one can also be possible like this. So this is actually the total number of trees which is possible. Any doubt in this?
Sir, what I thought when I'm rotating the four,
Yeah.
I got a square, right, sir?
Yeah, a square also you can form. You can also form a square and you can check. Suppose I have found a square. Okay. If you see, you can form a tree like this. You can form a tree like this. All nodes are connected. And you can also form a tree like this. 2 second. You can also form a tree like this. Okay. So the four trees are possible in the square also. That is a planar network. That is similar. If you see here, this is also similar. And this is also similar to this. Getting my point? If you're forming a square also, you will get the same answer with the orientations. Any doubt?
yes.
Okay. I hope I have cleared this. So let me see how many cut sets are possible. Suppose this is I'm getting A node, B node, C node, and D node. Suppose this is the B node, A node, C node, D node. Here also A, B, C, D. Here also A, B, C, D, A, B, C, and D. Okay. Let's move to the first part, first tree. If you see at node C, whether it a cut set is possible or not. The cut set is possible. Why? Because only one twig and any number of links are there. What about at D? It is not possible. There are two twigs. Okay. So the cut set is possible here. What about the B? Here also the cut set is possible. Okay. One twig is there. So how many cut sets are here? There are two cut sets at two nodes. And this, if you see the D node, okay, here also the cut set is possible. Okay, so this is a one cut set which is possible here, and also cut set which is possible here. So how many cut set? Two cut sets. And for this it is similar because this node we have already find it out. Okay, For the A and for the B, we have already find it out. Okay. So you don't have to repeat it. Okay. Whatever nodes you have considered, you have to take care of that only. What node we have seen here, that's C, D here, A and B here. Okay. Now one more important thing. If you see this part here, this point, okay, and this is the dotted part. Here also one cut set is possible. Okay, whether it is a loop or not, whether it is a node or not. Okay, there's a no node here, but you don't have to go with the node itself. You have to see the whether it is possible to make a cut set out of that tracer itself or not. So here it is not possible. Okay, so now I am moving from the node plus the situation forming at a particular
Why
place.
it's not possible this?
This is not possible because if you see, oh, actually it is possible. So let me remove that. Sorry. Either it is possible. Suppose I am forming a cut set here like this. Okay. So you can make a two graphs out of making a cut set at that point itself. Okay. When you cut this point, you will form a cut set. Means a sub graph out of that. Okay. Why? Because there is a one twig and one link is there. Okay. That's why a one cut set is possible here and one cut set is possible here. Okay. One twig here, one link is here. Okay. That's why the two cut sets are possible, one here, one here. So that's why its count will be the 6. So the correct option will come out to be C option. Any doubt?
So therefore, in the third diagram, cut set is possible, no, sir.
In the third diagram and the fourth diagram, there is a cut set are possible, but that nodes C and D we have already taken in the first. Okay. So you don't have to repeat the nodes. At that particular node, it is possible. You just have to see that A node, it is possible. Whether it is any number of means trees are there. If it is possible at A, it means it is possible. But that cut set doesn't divide. Yes, it doesn't mean that it have to divide it in the two. Means equally divide. It can be divided in the any manner. Suppose like this. Suppose I found a cut set here. It means that it will be cutted like this. Getting my point? So that cut set will be there like this. I will cut it like that. Suppose this and this was there. So we have cut it like this. So this will be a one graph, subgraph will be possible here. Okay. So you just have to see at any points or any portion whether it is cut set is possible or not. Okay. You can see from suppose let me take one example. Suppose I am taking like this one here like this. Let me take one example like this. If it is a situation arriving that a one mystery is being formed like this, okay, and this is the dotted parts, okay. So at this node it is possible, and you can also see with this also this portions as well, okay. Whether that branches you have to remove basically from where we have forming the cut sets, okay. You can see from here as well, apart from the nodes as well. But here it is already their node, it is a similar manner. You can also see from here as well. That is similar, okay? You can see from here as well, okay? You just have to remove that branches which are coming into the cut sets, okay? You can make a subgraph out of that. That's how the cut set is being made. Nodes are there, but also you have to see, observe whether from any point, whether it is a cutting into the subparts or not. But the basic definition should be the same, that one twig and any number of links. Getting my point? So that's it for the today's session. I will upload the this tutorial session video also, then last also. Due to the holidays, I was not able to upload that. Okay, so that's yeah. Any doubt?
Yes, sir. I have one personal question, sir.
Yeah, yeah, you can say. You can ask if you want. If it is personal, you can write to me directly. Whether it is possible to directly send message or not. Or you can message me at the LinkedIn also. You can search. I'm writing. I'm on the LinkedIn. You can just search my name and IIT Bombay. You will find it on my LinkedIn profile. You can ask any question there. I will reply that there. This is the my name, and then you just find it out with the IIT Bombay name. Okay. Satyavikram Pratap Singh, IIT Bombay. Okay. You can take the screenshot of that. You can message me there. I will reply. Okay. Okay. Thank you so much. Okay.
Sir,
Yeah. You wanted to ask anything?
yes, sir.
Okay.
Sir, I'm in second year, sir. If I prepare for GATE, can I crack it in the third year, sir?
Yeah, don't go with the mindset of the cracking it. Just try to means understand the concept. You will already will be covered if you are covering all the concept, you will be able to crack it. Go with the first. You don't have to go with that I have to crack. You just have to learn the concept. Then the gate exam will be already being means cracked by itself. Okay. You go with the means fundamentals. Okay. So the
Yes, sir, but I should balance both college and this
so I have
matter.
also everybody is balancing, so you have to do in that manner that you have to balance both. Okay, you have to ask the questions, you have to solve the problems. That extra hours you have to give, you can solve it, and you can crack it. Okay, so in
Sir, for that,
uh, uh, we will
social,
so if you have extra doubts, you can take it. You can just message me on the LinkedIn. I will answer that. Okay. So there is a one thing I have to experiment. I have to do one experiment. So okay, you can message me on the LinkedIn. We will see that. Okay.
yes, sir.
Okay.
To prepare,
Yeah.
which book can I refer, or should I go with
Uh,
the
book is the fundamental. NPT lectures are enough, and get one solution means question bank that it will be more fruitful. Or the great previous. First, see the great previous year. Whatever topic you are learning, see the great previous year and then jump to the particular book and all. Okay, the NPTEL lectures are enough, or you can read the book also, but I don't recommend that. But the reading the book is very lengthy process. Okay, for the gate it is not being helpful. Okay,
sir, but NPTEL lectures are have extra content.
yeah, but you have to read that only which is there in the syllabus. See the gate syllabus, try to cover that portion only. Getting my point?
Okay,
Okay,
yes, sir.
okay, okay. Thank you
Thank
so
you.
much.